So let's talk about Poisson distribution. Poisson distribution is discrete. It is not continuous, meaning that's countable. So the outcome is whether 1 or 2 or 5. It's not like 5.5, 2.2. Also, probability of an event is the same for all trials. You know, a really good example of that is birth of children. So let's say in a hospital, they can say that in average, in a given hour, 2 children are born. You know, the birth of those 2 children, and say 10 o'clock in the morning, is, you know, that probability is the same for 11, for 12. So for all trials, for any time that we are going to be using Poisson, the probability of the event is the same. The other example, famous example, is if you go to, you know, this geyser that erupts from the, you know, from under the ground. And so the probability of that is the same for any given hour that you want to calculate. The other thing about Poisson is the number of outcomes in one interval is independent from the other intervals. I think it's best to have one example to clear this up. Let me go to the next page. And here's the example that hopefully clear things up for you. A newspaper finds that the mean number of typo or typographical errors per page is 4. Okay, let me just show. Find the probability. Find the probability that the number of typographical errors found in any given page is A, exactly 3, B, at most 3, C, more than 3. Okay, so let's go back to the first page and see, does this qualify for Poisson? Okay. So we know that the mean errors of typographical for this problem is 4. Is it discrete? Yes, because, you know, there is a type of none or 1 error or 2 errors or 3 misspelling, 4 misspelling, 5 spell, you know, so there's nothing in between. You can say that, you know, I have 5.5 errors in this page. So it is discrete. The probability of an event is the same for all trials. Okay, we can, you know, we can assume that because we are told that the mean is 4. And for the third one, the number of outcomes in one interval is independent. So, the number of errors in one, like page 7 today is independent from page 5 yesterday. They don't, intermingle. They don't have any effect on each other. So it does qualify for Poisson. So let's go ahead and try to answer our questions. For part A, it's asking exactly 3. What is it that we know? We know that P of X equals mu to the X, e to the minus mu X factorial. And with the understanding that mu is the mean and X is the one that we are looking for, of course. So let's see. And here is the formula. And E is a number in your calculator. If you're not familiar with it, nothing to worry. There's a button in your calculator, E, which is 2 point. It's an irrational number like pi. The digits never end, but 2.71828 is good enough. All right, so for the first part A, that is asking probability of exactly 3, we can say P of 3 equals, what was the mean, the mu? We know that the mu was given to us as 4. So I have 4 to the power of 3, because that's the one we are calculating. It's asking exactly 3, times e to the power of minus 4 divided by 3 factorial, which is 3 times 2 times 1. And put that in your calculator. At least my calculator gave me 0.195, or you can say, 19.5%. Let's go to part B. Part B is saying at most 3, B at most 3. What does that mean? That means that probability of 0 error, or probability of 1, 2, 3, nothing more than that. So I'm going to claim that probability of X to be smaller than or equal to 3 equals probability of having no error plus probability of having 1 plus P of 2, excuse me, plus P of 3. So we have to use that formula 4 times for this part. And I have already done that. I didn't want this video to be too long. So this almost equals to 0.018 plus 0.073 plus 0.147 plus 0.195. And I'm going to say almost equal, because I rounded it to 3 digits, 0.433 or 43.3%. So the probability of having at most 3 errors is 43.3%. Now, the last part is something that we have to be careful with. Part C is saying that more than 3, more than 3. So here, if I say P of X to be greater than 3, if I say, P of 0 plus P of, well, more than 3, actually, I shouldn't say P of 0, P of 4 plus P of 5 plus P of 6 plus P of 7, and on and on and on. It's going to take forever. And really, nobody has the time to go and count the number of words to see when to stop. There is no real answer to that. So what do? We use the complement. We say that P of x greater than 3 is the same as its complement, which is 1 minus P of x smaller than or equal to 3. Because remember, all probabilities have to add up to 100% or 1. So P of x should be greater than 3 equals 1 minus P of x to be smaller than or equal to 3. And so 1 minus the probability of x to be smaller than or equal to 3, we already found it in part B, so I don't have to do any work for it. 0.433, and that gives me 0.567. So there's a 56.7% chance that there are more than 3 errors. Okay, I hope this was clear enough for you. Thanks.